The answer to number 33 is -6, 34 is 0, 35 is 24, 36 is 30, 37 is -10, 38 is 68, 39 is 17, 40 is -36, 41A is 13, B is -10, C is 0, D is 30, 42A is 3, B is 1, C is 0, D is 5, 43A, 8, B, -12, C, -4, and D, 30. For 44, we got -5 for A, B is 10, C is 0, and D is 15. And that is it for your homework. The next thing that we're going to learn is the actual other fundamental principle of calculus. The first fundamental principle of calculus is that the first derivative gives the slope of a tangent line to any curve. The second fundamental theorem of calculus is that if you find the definite integral of a function, you'll get the area under a curve. So if this is our function and it's the curve, and we want to find the area between the curve and the x-axis, we can do so by finding the antiderivative and then plugging in those values here from x to x when it wants us to go through. So let's try some examples. Alright, this first equation is 2 plus x, which would be a linear equation. And it wants us to find the area of that curve from 0, x equals 0, to x equals 4. So it wants us to find the area under here. It will always be the x-axis that it wants you to go to. Eventually, when you get into Calc 2 and 3, that will come below the x-axis, and you'll have to do a little bit more work. So what we do is we're going to do the antiderivative of 2 plus x. So the antiderivative of 2 is 2x. The antiderivative of x is x squared divided by 2 plus c. So what you're going to do, that's the exact same thing that you've been doing, but now what we're going to do is we're going to plug in these values for x. So we're going to plug 4 in, and you always do the top value, and then you do the bottom value. So if we plug 4 in for x, you will get 8 plus 8, which is 16 plus c. What you're going to do is you're going to take that value and you're going to subtract off what you would get when you plug 0 into this. So we're going to go 2 times 0 plus 0 squared over 2 plus c. So you would just get minus and 0, 0, so c. So the c's cancel, and you get 16. So the area underneath here would be 16 units squared. So let's try this example. We want to go from -1 to 1 on our x-axis, and we want to do the area under the curve of t squared plus 2 to our x-axis. So we do the antiderivative, and we get t cubed divided by 3 plus 2t plus c. And we want to evaluate it at 1 and -1. So we plug in 1. And you get 1/3 plus 2, so 2 and 1/3 plus c minus, now we're going to plug in the bottom value of -1 squared plus 2. Oh, I'm doing it to the wrong one. I was plugging into the original. I need to plug into my antiderivative. So we got -1 cubed over 3 plus 2 times -1 plus c. So when we put in -1, you get -1/3 and -2. So you get -2 and 1/3 plus c. Now we want to subtract off that whole back part. So 2 and 1/3 minus -2 and 1/3 is not 0. It is 4 and 2/3. C minus C cancels. Will the C's always cancel? They will. So you get 4 2/3 for your answer there. So do it again. Find the antiderivative of 4t cubed minus 2t. And we're going from -1 to 1. So we do our antiderivative, and we get just t to the 4th minus t squared plus c. So we put in 1, and we put in -1. So 1 to the 4th minus 1 squared is 0. So you get 0 plus c. Here, -1 to the 4th minus -1 squared is also 0. So you get minus 0 plus c. So your area on this one is 0 units squared. Alright, for this one, we are going to do our antiderivative of x to the 4th plus 2x squared minus 5. And we're going from -2 to 2. So we do the antiderivative of x to the 4th, and you get x to the 5th over 5, plus the antiderivative of 2x squared is 2x cubed over 3. The antiderivative of -5 is -5x plus c. I'm going to plug in 2 and -2. So when I plug in 2, I get 1 11/15. I'm not going to worry about the c because it's going to cancel. So then I'm going to subtract when I put in -2. So I got -2 to the 5th over 5 plus 2 times -2 to the 3rd over 3 minus 5 times -2. We're going to subtract off that whole back part, and that's really sloppy, sorry. So we got, when we do that one, -1 11/15. So we're subtracting that, so you get -3 and about +3 7/15. And you add that. All right, here we go. We got x times x to the half. So we rewrite it before we do the antiderivative because we don't know how to do a product rule here. And you get x to the 3/2. So the antiderivative of that is x to the 5/2. And then 2/5 plus c. So if I plug in 9 and I subtract off what I get when I plug in 4, let's see what we get. So we got 2/5 times 9 to the 5/2 power, and you get 97.2 minus, now we're going to plug in 4, and you get 12.8. So if you subtract, you will get 84.4 units squared. Alright, so here's another example. We're going from 1 to 2. We want the antiderivative of 1 over x squared minus 1 over x cubed. So I have to rewrite both of them as negative exponents. So I'm going to add 1 and divide by the new, and add 1 and divide by the new. So I end up getting my antiderivative is -1 over x plus 1 over 2x squared plus c. So we're going to plug in 2. And then we are going to plug in 1. And when you plug in 2, you get -3/8. And when you plug in 1, you get -1/2. And so we have -3/8 plus 1/2, and that will get you an 1/8 for an area. All right, another one. We're going from 0 to 1, and we want the square root of x times 1 minus x. So you got to distribute. You get x to the 1/2 minus x to the 3/2. So we do our antiderivative, and we get x to the 3/2, which becomes 2/3 for a coefficient, minus x to the 5/2, and you get 2/5 for the coefficient there, plus c. So we're going to plug in 1. When you plug in 1, you get 2/3 minus 2/5, which is 4/15. When you plug in 0, you get 0. So when you subtract, you get 4/15. Alright, this is the same thing except for it doesn't set like the antiderivative up for you. You have to do that. So we're going to do the antiderivative of wherever they want us to find the area under. So they say we want the area of the region bounded by y equals 4x. So that's going to go right here. They want the area from y equals 0. That y equals 0 is your x-axis. So they want your x-axis to that line. So that doesn't affect anything that you write down. They want to go from x is 2 to x is 10. So we're going to go from 2 to 10. So do the antiderivative. You get 2x squared plus c. Plug in 10 and plug in 2. And when you plug in 10, you get 200. And when you plug in 2, you get 8. So 200 minus 8 is 192 units squared. See if you can set this one up on your own. So we're going to do the antiderivative of x squared plus 3x minus 1. And we're going from 4 to 10. So the antiderivative of x squared is 1/3 x cubed plus 3/2 x squared minus x plus c. So we're going to plug in 10. And we're going to plug in 4, and you're going to get an answer. So, sorry it's taking me so long to write this out. You can be computing this while I'm writing it out. Okay, so when you plug in 10, you get 473 1/3. When you plug in 4, you get 41 1/3. So if you subtract 473 1/3 minus 41 1/3, you get 432 units squared. And that is it for this section. Please come with questions over this next time. The new thing that you have to do as opposed to before is you have to plug in values once you find the antiderivative and get an answer.